Hi everyone, you're watching video note 6.6, solving by factoring, day 2, which means we're going to do more of what we did last time. Second day of it, so you're going to see some quirky things happen and also get very good at it. So you're going to solve each of these equations by factoring, and then you're going to verify using technology, which means you could look at a graph, and you could see where the zeros are, make sure you're right, and you could also look at a table, and you could make sure you're looking for the places where x, whatever that x value is, it gives you the 0 in the table. So let's just get right into this. You're going to set this equal to 0 because your y value will be 0. You're going to factor this as quickly as you know how, x and x. The numbers that make 35 are 7 and 5, and you want the 7 to be positive, the 5 to be negative to make a positive 2. Set your factors equal to 0. If you're not that good at factoring, then you're going to have to graph, look at the zeros, turn them into factors, and work backwards. It's going to feel a little bit weird, but that's what you got to do. X equals -7, and x equals, when I add the 5 over to the other side, x equals 5. So this next one's a little weird because it's got a 3 GCF. If you just started factoring and didn't notice that, your factors would be a little harder to deal with. We're going to take the 3 out. By dividing each thing by 3, you get x squared minus 10x plus 16. We're setting this equal to 0. That 3, if you divided it away right now, would actually just disappear. So you don't need that 3 when it's an equation. And you're allowed to factor what's left, x and x. 16 is 8 times 2. To make a positive, the signs have to be the same. They both must be negative. Okay. I was just noticing my smart recorder wasn't on. Didn't look like it was recording. Anyways, I get x equals 8 when I add the 8 over to the other side, and x equals 2. 8 and 2 would be my two zeros. On a table, that means that 2 would have a 0 and 8 would have a 0 if I looked at a table. This one is a little different. This one has a GCF also, but it's only got 2 terms. The GCF is x. Divide by x. Set it equal to 0. So the x comes out front, and unlike the 3 in the previous one, we can't just get rid of it. When you divide out the x, you get x and 12, and then you set each factor equal to 0, you get x equals 0, and subtract 12, you get -12. So remember, if there's a GCF of x, it actually leads to another possible root. On a table, it would actually be 0, 0. So you can't lose that. That is a possible root. In this case up here, 3 does not equal 0, so you get rid of it. So GCF of x creates a 0 at 0. All right, this one, let's try to factor this. X and x. The only way to make a 9 is 9 and 1 or 3 and 3. Never going to give you a 4. So this is one of those examples that's not factorable. And if it said solve by factoring, you can't. Oh, it said solve by factoring. You can't. So you're just going to say it's not factorable. So that's kind of quirky. Okay, we can even explore higher order polynomials, higher order also known as higher degree, on a limited basis. You're going to do more of this in Algebra 2 and in pre-calc, but we're going to look at a cubic, x cubed. So what they want you to do in this equation, or in this example, is find the equation of this cubic, and it says verify using technology. So to find the equation, you start with where the roots are. The roots are at -2, +1, and +3. -2, 1, and 3. Make those into factors. So the factors are x plus 2, change the sign, x minus 1, I change the sign, and x minus 3. Technically, y equals, that's my equation. You could multiply this out. Maybe take them 2 at a time and multiply these together. x squared minus x plus 2x minus 2. I'm just double distributing here. You could use the box method to help you. That's x squared plus x minus 2. And then multiply that by the x minus 3. This is going to be a little bit messy. Everybody needs to be multiplied by x. So this would be x cubed. What I'm doing now is trying to get it into standard form. Like I said, this is an answer, but I'm trying to get it in standard form. X cubed plus x squared minus 2x. And then everybody needs to get multiplied by the negative 3. So all three of these are going to the negative 3 now. So it'd be a negative 3 on the x squared, a negative 3 on the x, and negative 2 times negative 3 is a positive 6. Now I'm going to combine like terms. There's only one of those x cubes. X squareds, I see negative 2x squareds. That's a 1, take away 3. On my x's, I see a negative 5x, and the 6 is the only constant. That, if I graphed it, would be the graph that I was looking for. So the equation can be written in factored form, or multiply it all out and get standard form. Okay, on this page, wait a minute, something just caught my eye there. Was that exercise 3 already? Nope, it was exercise 2. Okay, on exercise 3, we're going to consider this cubic function, and we're going to find the zeros algebraically. So when I look at this, first I want it to be equal to 0 because it said I'm finding the zeros. Then I'm looking at the algebra thinking, how can I factor this? So I see that they have a GCF. There's an x in both of these. Basically divide out the x, put the x in front, and I get x squared minus 9. Then I notice I have a dots problem. This is a difference of two squares, x and x, 3 and 3, plus and minus. And then I set each factor equal to 0. That one gives me a 0. This one gives me negative 3. This one gives me 3. So I found the zeros, 0, negative 3, and 3. Use your calculator to sketch this graph. So let's see, I think I already did a graph of this, x cubed minus 9x. Yep, there it is. So I did a little graph. I hope you can see that. And I found the zeros, negative 3, 0, and 3. And that's what my graph looks like. I'm also remembering, let's see, here's a 0, negative 3, positive 3. I'm also remembering some talk we had earlier, in my class anyways, that these tails go one up and one down on a cubic, just like the general shape of x cubed, which doesn't really have that dip in it. Okay, so anyways, there's my graph, labeling the zeros, negative 3, 0, and 3. Oh, that's all I had to do with that. I was just confirming it. Okay, exercise 4. I'm going to consider this graph now. I'm back to a x squared graph. Find the zeros algebraically using factoring. X and x, 5 and 3 make a 15. Both negative. To make a positive 15, I need a negative 5 and a negative 3 to give me that negative 8 when I add them together. Set your factors equal to 0. This is a 5. This is a 3. There's my zeros. Write the quadratic function in vertex form. Hopefully you remember that means complete the square. Complete the square. You should write that down too, because vertex form and complete the square need to be connected in your brain. So we're going to take y equals x squared minus 8x plus 15. Oops, wait a minute. We're going to make a space here. We're going to put the plus 15 down here a little bit. This factors into x and x minus 4 minus 4. Okay, so if you remember what I just did there is I split the negative 8 into two equal pieces. I'm completing the square. So I split the negative 8 into two equal pieces, negative 4, negative 4. That makes my perfect square, x minus 4 squared, but I put a 16 in by doing that. So I need to offset that, taking away 16. That gives me a minus 1. My vertex, write the function in vertex form, identify the coordinates of the turning point or vertex. My vertex is change the sign on the 4, -1. So here's vertex form, and there's that. Don't lose the square here. You created a perfect square right there. What is true about the x-coordinate of the turning point compared to the zeros you found in A? Well, if you look, the x value of the vertex is 4, and the zeros were at 5, which is 1 that way. Hold on a second. Let me find out what these dogs are doing. Okay, so 5 is 1 that way, and 3 is 1 in the other direction. In other words, it's smack dab between the two zeros. So what I'm trying to say is 1, 2, 3, 4, 5. The zeros are perfectly surrounding the vertex at 4, -1. There's symmetry, 1 that way, 1 that way, symmetry. Exercise 5, last one. Quadratic function can be written in this form, otherwise known as factored form. And which of the following would be the x-coordinate of its turning point? So they're trying to trick you here. They want you to realize the roots are at -3 and 7, if you solve that algebraically, -3 and 7. So a little bit of a sketch here, -3, 7. From what we just said in exercise 4, our turning point would have to be halfway. So it can't be 6. It can't be, well, it might be 2. Probably not 5. What's halfway between -3 and 7? That's a gap of 10 units. So count back 5, and yep, it's 2. Split that into 2 5s, halfway, halfway. 7 take away 5, x equals 2. So I used symmetry to figure that out. X equals 2.